So in this video, we're going to complete this question here where it gives us one common point to both laminas and it asks us to find the dihedral angle between the two planes. So they didn't give us any coordinates to plot on this one in the example. So these are the coordinates I've used. I've made up my own coordinates there up the top corner. And that's the two laminas plotted in the plan and elevation. So my next step is to get that line of intersection. So we know the line of intersection is going to be going from corner A down here somewhere. Okay, because corner A is common to both of my laminas, corner touching like that, it's going to be running down in between the two laminas from the corner that's common to both. So how do we find that line of intersection? So in elevation, we draw a level line that goes through the two laminas touching each side. What we try to do is go through a corner of one of the laminas. Okay, it just makes it easier for finding it down in plan, finding this level line down in plan. So I'm going to go from here right through point D and continue with that. So I'm going to call here 1, I'm going to call outside here 2, and I'm going to call here 3. So this level line now in the triangle ABC hits 1 and 2 on the corresponding lines there of the triangle. So line AB, we've point 1. So what I'm going to do is I'm going to bring point 1 down to plan until it hits the line AB, which is there. So that's 1. Line AC is cut by 2. I'm going to bring down 2 until it hits the line AC. So that's line AC there. So this is point 2. D is simple because it's D, it's down here already for us. And AE is cut by number 3. So bring down AE to find number 3. I'm going to join my corresponding points now. So 1 and 2 get joined because that's on the big lamina. And D and 3 get joined on the smaller one there then. So D and 3 and 1 and 2. Where that small little X is made there in the center, that's a point on the line of intersection in my lamina. So what I'm going to do, we said it goes from corner A, and the line of intersection always travels until it meets the first line of a lamina. So I'm going to stop it there then, where it meets that first line of that one. So that red line there is my line of intersection. If we want to find that in elevation then, we can just bring it straight up. So it's on the line BC. So bring it straight up to BC, which is there. And we can join that back to A then as well. So that's my line of intersection in elevation. So that's that part solved, okay? Now in the question, it wants to find the dihedral angle between the two planes, okay? So once we have our line of intersection, it becomes kind of repetitive at this point. So we need to set up an x1, y1 parallel to that line of intersection to give us a true length of the line of intersection. So, change my colors, we go with blue. Okay? I'm going to set an x1, y1 parallel with this line of intersection. And that's going to give me a true length of the line of intersection. So I'm going to bring up all my points here. I'm going back 2 views, so 1 view, 2 view. So I'm going back to my elevation there then for my heights. I'm going to set a little datum up in the elevation as well, just so I'm shortening that distance between the XY line and the heights. So B and E are on it. So E is there. That's E. And B is also on the ground. Point A is this distance from the datum. So point A. C. D, which is here. So I'm going to draw in my laminas again up in this auxiliary elevation. So called A, B, C. And it goes A, D, A, D, E. Okay. What I'm going to do next, I'm going to bring up my line of intersection. So my line of intersection starts in corner A and it cuts B, C at this point. So I'm going to bring up this point down here to where it cuts the line BC, which is there. Okay. So what I'm going to do now is I'm going to get my rate just to make that stand out. Join it from corner A down. So that's a true length of line of intersection. Okay. Why is it a true length? Because my x1, y1 is parallel with my line of intersection, meaning the next view is the true length. So that's my true length there of my line of intersection. Now to get this dihedral angle, I need to see or view this true length as a point view. Okay. So I'm going to set up an x2, y2 perpendicular to that true length line. That's my true length line. I'll go perpendicular for my x2, y2. Once again now I'm going to bring down all my points of my laminas. So that's I'm going to mark off my distances. So from one view, two view. So it's going to be from my plan to my x1, y1. But I don't want all this empty space here because my drawing is going to end way down the page. So what I'm going to do, I'm going to set a datum up here parallel to this x1, y1 that just runs through the plan, or the closest corner on the plan. So C, I'd say. Yeah, it's just going to touch corner C, meaning C is going to be on the ground here. So that again. Now I'm going to transfer across my heights. So C is on the ground, C, E is this distance from the datum, E, D here, and B. Yeah, so once again now, I can join my point. Ooh, that one is, so this is B, not D. And then that's D, yeah. This is actually E. So E is there, and my D then is across here, D. So be careful with your labeling. Now we can join our points, so D goes down to E, through A, and C goes through A and up to B then. So what you get, or what you should get, is this X shape, and any one of those angles can be labeled as the dihedral angle, so I'll just label this one here. Doesn't matter which one of these, each one of these could be the dihedral angle. So, that's the question found out. That's the dihedral angle between two laminas, two planes, with one common point on each of the laminas.